Welcome to day 2 of solving trig equations using identities. These get a little more complicated than the first day, but you can handle it. One thing to highlight right here, it says you must also recognize need to use an identity. Okay? Alrighty. Solve for all values of x. These are a quick review. You set sign of x equals negative a half. They want all values, so it's negative 1/2. Think about your unit circle here and here. So you have 7 pi over 6, 11 pi over 6, and I'm going to add 2 pi k because I go run around the circle and get back to the same spot. Another one, basic, get our brains back after vacation. I hope you all had a great vacation. Okay, remember that's the same as root 2 over 2. You know that's a pi over 4. Cosine's positive in the first quadrant, and the fourth quadrant at 2 pi k. Oh, all right, this one you have to factor. So I pull out tangent, and then you end up with a tangent of x minus 1. Remember, you always leave it set equal to 0, then set both factors equal to 0. The tangent 0 at 0 pi, 2 pi, 3 pi, so that's pi k. And the tangent's 1 at pi over 4. It's in the first and third quadrant, so I don't have to do 2 pi. I can just do pi k because it's halfway around the circle. All right. This one, you always set it equal to 0. Then this is a double angle, so I'm going to substitute my double angle identity. 2 sine x cosine x minus cosine x. Now factor out the cosine, and you get 2 sine x. 2 sine x minus 1. So you need to know when the cosine of x equals 0 and the sine of x equals a half. The cosine is 0 at pi over 2 and 3 pi over 2, so it's pi over 2 plus pi k. And the sine is 1/2 at positive pi over 6 plus 2 pi k, and 5 pi over 6 plus 2 pi k. All right, now this is another double angle. I got to use a double angle identity. On this one, there's lots to choose from, but I chose 2 cosine squared x minus 1 plus cosine x plus 1. These guys go away. So I pull out a cosine x, and I'm left with 2 cosine x minus 1. The cosine of x equals 0, and the cosine of x equals a half. This is pi over 2 plus pi k. And this is pi over 3 and 5 pi over 3 plus 2 pi k. All right, this one we squished in there because we knew we needed some multiple angles. Remember, that's changing the period so that how frequently it equals a value is going to change. So you have 2 sine squared of 3x minus sine of 3x equals 0. So you set it equal to 0. You're going to factor out the sine of 3x, and you're left with 2 sine of 3x minus 1. And then the sine of 3x equals 0. And the sine of 3x equals a half. Now, what happens is 3x you're looking for the angle that equals 0. So the sine is 0 at 0 and pi and 2 pi, etc. So it's pi plus pi k. Now remember, this changes the period. You're going to divide by 3. So x is equal to pi over 3 plus pi over 3k. Because it's halfway around the circle. Remember, the new period, you have 2 pi divided by b, 2 pi divided by 3, but we only need half of that because the sign is 0 here and here. It's halfway around. All right, the sign at a half is at pi over 6 and 5 pi over 6, just like it was for this problem. The difference is my period changed. So my period is 2 pi over 3k and 2 pi over 3k. Right? Pay attention. That's really, really a tricky point, something we do, okay, because it's a 3x. Pay attention to that. Okay. This one we changed our interval to go just 0 to 2 pi. I have to do a substitution here. I replace tangent squared with secant squared x minus 1 plus the secant of x, and I bring this 1 over here, so you have another minus 1. Secant squared x plus secant of x minus 2. You factor it. I have the secant of x, and I have a 1 and a 2 because it's the only way to get to 2. That's positive, so this one's negative and that's positive. The secant of x equals 1, and the secant of x equals negative 2. Be careful, because you think, oh, it can't be greater than 1. This is the secant. It's the reciprocal of the cosine. So it's asking us, when is the cosine equal to 1, and when is the cosine equal to negative 1/2? And the only want the ones on that closed interval. So the cosine's 1 only at 0 and 2 pi. The cosine's negative 1/2 at 2 pi over 3 and 4 pi over 3. Okay? This one we put in 4x. So you end up with the cosecant squared of 4x minus 3 cosecant of 4x plus 2. And you got a factor. So I have the cosecant of x and the cosecant of x. 2 and 1 are the only choices. Since it's negative 3 in the middle, they're both negative. So I have the cosecant of x equals 2 and the cosecant of x equals 1, which means that the sine of x is equal to 1/2 and the sine of x equals 1. The sine is 1/2. Oh, this should be a 4, sorry. Oh my goodness, let's fix all of those. They're all wrong. Should be the cosecant of 4x. Good thing I caught it. You guys probably caught it a long time ago and tried to tell me. Well, we've got to fix these too. Yeah, I'm as bad as the notes itself. So that's a 4x and 4x. So 4x is pi over 6 and 5 pi over 6. And here you have 4x equals, when sine equal 1 pi over 2. Then you have to solve for x, so you have pi over 24 and 5 pi over 24. And this is equals pi over 8. Now, remember, the period is 2 pi divided by b, so it's pi over 2. And pi over 2 is 12 pi. Oh, I did the same thing over here. No, I'm all right. It was this one. We're right. Never mind. 12 pi over 24. Yep, I got to come back and fix that. Hang on. So if you add 12 pi over 24 to this, you get 13 pi over 24 and 17 pi over 24. Here you get 20 pi over 24. Okay, lots of them. Is that right? No. Boy, I must still be on spring break. Sorry. 12 and 1 is 13 pi over 24. And then we needed to add there we go. Can I add pi over 12 again? You get 17? Yeah, we got them. I think I got them all. All right, up here we forgot to make this 3x equals pi over 6 and 5 pi over 6. So this needs to be pi over 18 and 5 pi over 18. Okay? Much better.